Good day everyone and welcome to this session in which you will learn how debugging PowerServer 2021 applications. Usual disclaimer for presentation ordered by volunteers in the Appium community. And let's start with the session agenda. A breakdown of the operations and functions to debug in PowerServer 2021 applications. The session will recap what you can do today for client-side debugging. Then we will move to server-side debugging, a new concept if your background is client-server only application. And you will learn what are the right debugging tools and how to use the appropriate technique. Among the others, Fiddler represents a very powerful and flexible tool. This session also describes useful file logs produced during the deployment and running of PowerServer projects. And in the end, a few debugging case studies will be discussed to showcase how to handle real-world issues and locate errors occurring during the application execution, with specific regards to data window-related errors. Short presentation of myself. I'm a PowerServer enthusiast from the early days in 2003. I have been and I am involved in lots of migration projects to PowerServer web and mobile. I am Appium MVP. I began programming PowerBuilder with version 4.0. Over the last couple of years, I have developed plugin-free web UI using Vue.js and Quasar frameworks on top of REST API developed with SnapDevelop. I gave a long step-by-step session about this at Elevate last year. Other than that, I spent quite a long time in the recent past working with machine learning algorithms and big data infrastructure. PowerServer projects have the typical web application structure consisting of client and server sides. The client side contains the functionality that a user interacts with, and the server side deals with the database operations. Connection points between the two sides of the wire are the Internet Protocol and the REST architecture, with client submitting HTTP GET to fetch data rather than HTTP POST, PUT, or DELETE to inform the .NET server that a given resource must be created, updated, or removed. Therefore, you need to first decide what operations and function you will be debugging and then choose the right debugging technique and tool. For client-side debugging, you can set breakpoints in the source code and debug the application from PowerBuilder like in a classic client-server mode. In fact, the ICA front-end code is powered by PBVM. It is a Windows native client for which you can continue to use the PowerBuilder debugger for operations with no database interactions, like PowerScript in UI components where you are performing, for example, menu navigation or UI theme adjustments, scripts or MVOs manipulating on the client side data window data store data, for example, loops, sort, filter, shuffle, all operations running on the client side. Access to external components like DLL or OLE, but also web service that maybe you are connecting using the PB HTTP client object, and so on, as long as step in, step out, and step over are not related to server calls. Worth to mention that in PowerBuilder 2022 will most likely feature full-fledged built-in debugger. Since an installable cloud app is an internet deployable native app powered by PBVM with a cloud-native architecture, we will be able to debug the installable cloud app from within PB while interacting with the server part, which is running in the .NET server. Server-side debugging consists of identifying client requests that interact with PowerServer or database, inspect the traffic between the client side of an ICA and PowerServer, use a web debugging proxy tool to capture HTTP, HTTPS traffic between the client and the server, identify where potential failures are, whether they are originated by the client or the issues are on the server or the PowerServer REST API services. Let me introduce you Fiddler, a debugging proxy tool from Telerik to capture HTTP and HTTPS traffic. So just download the tool, start it, and you'll be asked at the beginning to install Fiddler certificate on your machine. Just click on it and continue. Next, tick the option to decrypt HTTPS traffic because you may have your API deployed to HTTPS server. And an additional setting down here, by default Fiddler doesn't come with modern TLS versions enabled like TLS 1.1 and TLS 1.2, so if that is your case, just add the proper setting, like in this example here that enables 1.1, 1.2. And to enable that Fiddler can successfully capture the traffic, make sure that the Web API URL setting of the PowerServer project uses the actual IP address, not localhost. So for example, here in the Web API panel of PowerServer project in PB, I have specified the remote hostname where the API is deployed. Next, let's see how to inspect HTTP request and response when a session is created. Here you can see Sales Demo running as an installable cloud app. And in the Fiddler tool, you will see the requests sent to PowerServer in the section containing the list of sessions here on the left pane. While on the right pane, you can see the full HTTP request above and HTTP response below. If the response body is encoded, you will see an option to decode it. Just click on this option to get JSON body fully readable, like in this example. And here you can see information about the session with transaction detail and the typical Power Builder transaction object properties. So it's very cool to have full evidence of what the .NET server is doing. It is a daunting task to check through hundreds of requests. Therefore, you may want to analyze database operations more efficiently and use filters to filter out the results. Again, here you have a Sales Demo app running and Fiddler on top, so you can check the JSON or the text view panes and the header here to verify HTTP status code, which gives you immediate understanding of why an app may be failing. It is here that you will learn maybe HTTP errors like 502, meaning the request is blocked or delayed by firewall or load balancer, or 404, meaning the resource was not found. Or more Power Builder like, you will be able to check Power Builder transaction SQL code, SQL error text, telling you possibly wrong database operation, which will take you later to analyze the C# data store model files, the data window composition to check possible retrieval errors, the data types mapping between the original data window and the C# model, or the data type returned by PowerServer on executing syntax from SQL. For example, I personally had an issue with data store update failure because the original Oracle column was a number 18,4 and that was mapped to a decimal 0, losing therefore the decimal digits. In addition, there are plenty of log files that help you understanding runtime failures. And Here is the list. Shortly, we will discuss them one by one. Let's start with deployment log, which is created when the project is deployed. Unsupported feature report, like in the classic PowerServer, it shows the list of PowerBuilder features not supported during PowerServer migration. Web file download log, just in case you may have some firewall or context filter blocking file download to the client. Web API request log that contains full list of server calls. Snap develop debugging log, PowerServer log, more specifically log for net framework, and login.json settings. Let's have a look in more details. Deployment log is located under log dir in PowerBuilder installation dir. It's like the old PowerServer web. It lists all cloud files being created and uploaded to selected server. The unsupported feature report in the output window lists all PowerBuilder language features that are not supported yet by the PowerServer web API. And the PowerScript features will be analyzed during the build and deploy process. So remember that not every unsupported feature can be detected. Therefore, have a look at this link where you can find for description of code type that may lead to unsupported feature, in particular for code that has to do with syntax from SQL, retrieve row event, data type mismatch, unnamed columns in dynamic data window, etc. And make sure they do not exist in your application. Because as with the traditional PowerServer version 2021, and also offers functions, namely is PowerServer app, to detect if you're running client server or PowerServer, so that you can work around unsupported feature directly in the existing code. Logs are also available during the download steps. For the Cloud App Launcher, at this path with launcher or launcher with service based dir, whether the app launcher is executed with or without background services, and for the ICA itself. More about PowerServer log. If you don't want to use proxy tool like Fiddler to debug HTTP traffic, you can have full API log dump. Just modify the pb.ini with API log option and deploy the ini with the application. The full log will be stored under application name /log. Another way to debug the server API is from Snap Develop. You can start the server API project and check the server calls in the output console, which gets updated every time the ICA calls an API. Of course, you may get plenty of lines, so look for a specific keyword like SQL to filter out only SQL syntax. PowerServer log is stored under this default dir. You can change it in Server API projects log4net.config file, and you can also specify the level of verbosity in Server API project logging.development.json file. For example, level of SQL, and level of sessions, level of transactions. Let's now discuss a few debugging case studies about data window related errors. First, you may get an error. The property does not allow null value if the model generated from the data window has set non-nullable attribute to a column. This can be the result of this kind of SQL statement in data window retrieve, because You see, birthday add 1 is a computed column, so it shall be nullable. Another example is using the same model against different database. So suppose to execute the create table syntax in SQL Server and in Oracle. The first one will define the column as an int, while Oracle as a number. So the data window will define long data type for the ID column. Suppose in fact that you convert the data window to C# model connecting SQL Server data source. But this will produce incompatible data type error when the same model is used for Oracle. So in order to run the same model against different database, you need to add this value converter directive to the C# model. And the ID will be mapped to int or to number according to data type. Incompatible data type, for example, decimal type in data model is not compatible in PostgreSQL, where it must be double. So you can check at this link all mapping rules between the original database data window data type and the C# model data type. Or the data type returned by PowerServer on executing syntax from SQL. In this case, when getting compatible data type error, you would need to make necessary changes to the C# models or in the SQL syntax. But you can have even the application crashing when executing the same SQL statement of a normal data window through syntax from SQL. So Fiddler will help you understanding how to check. In the HTTP response panel, for example, here the column name is empty, as you can see, and it occurs when you have a computed column in the select, but without an explicit alias name. Then check the transaction SQL text, the improper data types, or mismatch in column length or position. All hints that you must take into account and cross-check in Fiddler in order to understand why your application is not returning the proper data or it's even crashing. Last, when the SQL preview event, which is executed at the client side, converts PowerBuilder select to select syntax, the event may cause the client to crash or arrive at incorrect SQL syntax. Especially if the syntax relies on disable bind the limit identifier settings in dbparm transaction object property. Faster solution is again to use Fiddler to verify the HTTP request and response, check whether a connect has occurred and whether the connection is successful, and if necessary change pbselect to a select statement in the application source code, which is always cleaner. In my personal experience so far with PowerServer 2021, debugging has been typically necessary for server-side logic. Client-side, unless you're using PowerBuilder unsupported objects described in the migration guide, is same as client-server because ICA is native, so runtime is the same. Plus, keep in mind, client-side debugger will come in the next PowerBuilder version. So whenever a runtime error has affected server calls in applications that I migrated so far, Fiddler has always given the proper answer to the majority of migration runtime issues. I had, for example, a big issue with data window update failure, and in the end, I find out that the problem was simply to cross-check the correct mapping between the data window column and the data model property. While for heavy data exchange requests, which are so common in legacy PowerBuilder applications because the habitude to fit in one long script tons of data window operations may be mixed up with embedded SQL. In such a case, the application needs a complete round trip per each SQL or data window operation, and therefore it will be slower than client server, and the analysis of execution time of each individual request has shown the need for a simplified code. Finally, a word on storage procedure in a rather complex data entry, which sends to the database not only structured data but also binary data. During the beta version of PowerServer, we found out unsupported block arguments for Oracle database, which has been promptly fixed by Appian in time for the GA edition. So overall experience with PowerServer 2021, personal experience, debugging is extremely positive, quite a number of log files informing in detail what's going on across the wire. Server API can be easily debugged on the dev machine running the API in debug mode and performing the step-by-step debugging from snap develop. Otherwise, if the code is already published to .NET Server, you can use Fiddler that offers full display, full search, and full filter functionality to understand the SQL executed at any time and the property of the database connections. Time for a demo. So let's switch to my Windows machine. I have PowerBuilder 2021 sales demo application available with the installation at this dir. And I've created PowerServer project. Important thing is how and where I deploy the web API. So PowerBuilder, as soon as you click on build and deploy the PowerServer project, will generate a snap develop solution. And this will be the host name and port number where I want to run my API, my server API. So a snap develop solution will be created with controllers and all the folders inside. In fact, I'm not going to run the web API on my local web container, but I will deploy to a Docker engine, a remote Docker engine, which is available at this machine on this port number. So in fact, I've built the image for sales demo. Here you can see that the exposed port number is 80, which is bound to a local port number, and the entry point is the command shell, which will run a server API that contains the main function as an entry point. I'm not gonna discuss how to build a Docker image, how to run the container, and how to have this API in the container connecting the remote SQL Anywhere 17 database. If you want to learn about that, you can follow my Elevate session Dockerized SQL Anywhere connection for your REST API and PowerServer 2021 projects. So I'll select the sales demo container and start it. So at this point, in fact, I have my server API running, and I can start the front end of my installable cloud app from PowerBuilder or from the desktop icon. And this is sales demo starting and connecting the remote REST API. Now, let's start Fiddler. You can download the tool, the proxy tool from telerik.com, download the trial. This is the tool. Don't forget, be sure to run the PowerServer web API before you start Fiddler. Otherwise, it will fail to start. Reason is Fiddler, as well as other web debugging proxy tool, works by adding itself as a proxy instead of using your current proxy settings. Therefore, it will change your proxy settings on startup and reverse them back to what they were when Fiddler is closed. So if I now click on any icon on sales demo, for example, customers, I will I will trigger a server call. I will ask the server API to return some data. And in fact, Fiddler, you see, it will start logging the session and all the requests to the server API. For example, let's take the first one. You can select inspector and then the JSON on the text view. On top, you have the request. You can also see the headers of the request. And below, you have the response, the HTTP response. Again, either the JSON or the headers, so you can get acquainted with the HTTP status code 200, 404, etc., etc. In our case, as soon as I click on the customer icon, I will get the list of these customers, the individual customers. And that's why the request says that the app name sales demo has trigger retrieve for the data window of the person list, providing an argument of type IN, probably the category individual, and below the response. So if I collapse it, I can see transaction information. So very nice to see from this proxy tool property related to Power Builder objects like the SQL code, SQL error text. I can see the content of the response, in particular the result set with the many lines. So one line per individual, one line per customers. You can add filters, especially if the number of sessions, the number of transactions being logged becomes too high. You can specify filters for the server names or which you want to monitor, request headers parameters, or response status code rather than response type and sites. Another thing which is very useful is to add customized column. For example, let's say you want to do some performance benchmark. You can select the session timers and overall elapsed to understand how long each request is taking. Now, let's create, for example, another request, again with customers. You will see that this list contains the main data window, probably a number of drop-down data windows, each one resulting in REST API call. You see many of them. You can see how long, how many milliseconds each REST API call is taking. Keep in touch with Appian Community Portal is the place to be, where you can find discussions, technical articles, video and free online tutorials, and of course follow up on social networks. Thank you very much for your attention. I will be happy to answer your questions in the next 10 minutes dedicated for chatting, and have a wonderful Elevate 2021 conference.